Good morning, everyone. Almost 8 months ago, we made a big release. First thing, the story, all names, character, and incidents portrayed in this production are fictitious. No identification with actual persons, living or deceased, places, buildings, and products is intended or should be inferred. I know we are mostly Europeans. That means English is a single language for us. So in plain English, this means, do not sue me, please. So the story behind, I'm going to talk about, it's under an NDA, so there are some details I cannot share with you. But as I was saying, we made a big release. It was a feature we've been working on for a few months. The press coverage was amazing. Everyone was loving it. We were really excited about it. Really, really excited. Having such good feedback, it's really good for your job. But suddenly, some sad news came. We had a leak in the server, like a massive leak. Welcome, everyone. This is a talk about FastFlood. It's a massive memory leak in FastFood. In FastFood, no, in FastBoot. So let me explain you. I'm Sergio Arbeo. You might know me as Serabe. I work at Dockyard. You already know Dockyard from my two coworkers that gave amazing talks yesterday. So I'm not gonna discuss Dockyard more. So what is a memory leak? A memory leak is basically this, something that the garbage collector should have collected and it's still there. Okay, I see some strange faces. Let me explain you with this. Okay. Yeah, you know what's coming. So imagine you have 1, 2, 3, 4, 5, and 6 variables in memory. And you drop 1, 2, and 3. You can even hear it. If you still have 1, 2, 3, 4, 5, and 6 variables in memory, that's a memory leak. The best thing is that you can keep dropping 1, 2, 3, and you still have 1, 2, 3, 4, 5, and 6. But remember, you can keep dropping 1, 2, 3, and still have 1, 2, 3, 4, 5, and 6. But we're in the server. That means it's not just one process running. So you drop 1, 2, 3. You still have 1, 2, 3, 4. Maybe a SUI, a Tomster, another SUI, the 5, another Tomster, SUI, and some deprecated features. So it's more or less clear now? Because I don't have more cards. Liar. But why is memory leak happening? 99.99999% of the time, it's the reference to that variable is being kept somewhere. Not to the variable itself, but the value at the variable. There's a slight chance it's a garbage collector bug, but really small. Usually when someone is found, someone of these cases is found, you get a nice blog post from the BA team. So if it's all about reference, we can create what it's an object memory graph. And we can have this. This is just all the reference, which object contains which and such. This is coming from Firefox. This is the only screenshot from Firefox you're going to see. The rest is going to be from Chrome. And I'll explain to you why later. But this is usually not useful. It's more useful this other view. In this view, we have a snapshot of our memory. We see the first row, that's the constructor. It has the name of the classes that are being held in memory. Then we have this other column called distance. That's the number of references that are from the level of depth starting in a GC root to our variable. So if you have Different levels for the same kind of object is usually a sign that something's not wrong. Something's wrong there. We have also the shallow size. This means the size of the object itself. And we have the retained size. This is how much memory would be free if we were to free that object. Okay, is more or less understood the difference between shallow and retain. And last but not least, we have the retainers. This is important because we can find a variable in the panel above and say, hey, send it to the retainers panel, and you will see what's retaining what. Sadly, this is not useful for FastBoot. It's a heap profile. Well, one moment, heap profile. But we can use it. This is really useful for most of our cases. That's in the front, in the browser itself. There's a cool technique called the 3-snapshot technique. What you do is first you warm up. By warming up, you're initializing everything you need in your app. You make a snapshot. That's our first snapshot, those three first objects. Then the action you think it's causing a memory leak. Do a second snapshot. Repeat the action and make a third snapshot. So you end up with 3 snapshots. By the way, the ones that the circles that faded away are supposed to be collected by the garbage collector. So with this information, what we can do is just use the 3-snapshot technique. We are interested in the objects in the third snapshot that were created after the first one, so we don't want those two in the first snapshot, but were created before the second snapshot. That means we are not interested in those 4 above. Why is this useful? Because then you only need to inspect like a small portion of your memory, not everything that's in there. But again, this is not useful for FastBoot because we cannot do that action. That action is just a request. It's more useful this other tool in the memory panel of the Chrome DevTools, and that's the timeline. If you see, it's the very same UI, except for the timeline above. What does that timeline mean? It has 3 lines. The units differed from time to time, just because it depends on how much memory is consuming your application. The blue bar means how much memory is being held right now, but you see that there are some gray part above, and that's the freed memory. Okay, have anyone used this before? And lucky you. So, but what to do with this? We are having a massive memory leak. We're having like 2 main problems. Well, let me first introduce you how to debug a memory leak in general. The first step is reproduce locally the memory leak. You need to have a production-ish build. So you don't really need to have the full production build because you might have some logger, some error reporting. You don't need that. If you cannot reproduce that with those turned off, that means that there's a leak there. But it's usually not there. And no glyphication. This is important so you can see the actual name of the classes in the memory. Step 1. In our case, we had two tasks. First, look for the leak, like with the tools we know, and look for changes between versions. Maybe a change in the version, we can see what was going on. Finding the leak can be painful But there are some steps that really need to be there, and that's from experience for several reasons. First, run the server. Then, make a manual request. This is for 2 reasons. The first one is it's a bit embarrassing, but you may break the build. You may break the build, you see that it's been broken. And if you don't do this manually, you won't see a thing. You just see that there's no memory consumption. You go, yay! And then you go to the CI tells you this is broken, and then you go chronically depressed for a couple of days. And second reason is because the first request to FastBoot consumes more memory than the rest. So it's an outlier and should not be in your timeline. Then you can start the timeline and make a few requests. We usually use the Apache benchmark tool. If you don't know it, it's just a tool that makes several requests. We added the concurrency one so we can see a nice graph in the timeline, but that's it. And then you inspect the memory. So far, so good. This is a cool technique we were using because if you have a class, you will see the class name in the inspector. But if you don't have one and you're exporting a Pojo, you can use one of these snippets. We call it leak detect. You can name it whatever you want, Macarena, Eurovision, we don't care, as long as you can look for it. In this case, it's just a leak detect. You can do new leak detect and pass the Pojo, and it will behave like the Pojo, except it will have a name. This is other version, and it's mostly the same, but it can be inlined. Step 2, find the Dominator. What's the Dominator, you might be asking? The Dominator is the closest parent that, whenever freed, will free your leak. Or we can also find the dependency if it was in our changes. Third step, remove the reference in the Dominator or change the dependency and win. That's all. Thank you for coming. If you have any questions, you can ask, maybe Chantal. Don't ask me. No. This is just the general rules. You might have seen this, but when you face a real problem, you need to improvise. And we had 2 big problems. The first one is that we were a team of 4 and we were fully distributed. There were 4 time zones, 4 people. And the other one is that we were leaking the container. If you don't know what the container is part of Ember, is the registry. It's like the private part of the owner if you have used it. So when you're leaking the container, that means you're screwed. That's what it means. So what we did, okay. First thing, look for owner leaking. Maybe we have changed some usage of the owner API. Maybe not us, maybe a dependency. So we spend a lot of time looking for owners. And update to latest Ember. We couldn't update to latest Ember because of reasons that I cannot tell you. Otherwise, there will be a lawyer sending me a letter, and that's not nice. Then we assigned tasks based on people's knowledge. There were 4 of us. One of us had updated a similar application that was hard to update for the same reasons. So that guy was tasked with updating Ember. The main developer behind the feature was tasked looking at the changes, not only looking at them, but documenting them, etc. And 2 of us were investigating them. There were the 2 of us that had more knowledge about debugging and finding memory leaks. Also, communication. If usually that communication is key in every development, at this process where there's some kind of pressure to fixing it, is really, really key. You need to communicate early, just to prevent duplication of efforts. So you're not doing the same task as other colleague of yours. You need to communicate often, just share the knowledge, and the most important is do rubber ducking. That's the most important part. At some point in time, you will feel like, I cannot do this, I cannot do this. And talking to your colleagues and checking your facts, it's a good way to go on. This is, for me, the thing that worked the best. It's take small victories before winning the war. First thing, victories are team victories. That means that nobody fixes the leak, the team fixes it. Because as we are splitting our task, if in this case it was me fixing the leak, but if it weren't for the rest of the team doing other things, I couldn't be finding the actual leak. So it's the team finding the leak, not me. Okay? Why is important taking small victories? First, the morale. As the time goes on, morale decreases, and it really does. Like in 3 days, you are in the shit. But if you take, yeah, I told my therapist, so that's okay. That wasn't a joke. But if you take small victories, you can decrease the pressure on your team. Why? Because if there's less memory consumption, you need to restart less the server. So the pressure starts to disappear. And also, as you see some progress, the morale starts to raise again. Also, it improves your code base. 2 reasons. Always, less memory consumption means more snappier apps, but also less memory to inspect to find the leak. But not at any price. For example, we had 2 fixes in the 2nd and the 4th day, I think they were. One I cannot discuss, but it made the memory consumption much, much less. And the other one was changing the code, so in FastBoot, some things weren't cached. And we were from 9 megabytes a request to under 5. So that's a lot. But for the laters, we reduced the memory, but we still consumed like 20 times the original memory. That was because there was a leak there. We didn't know about it because we didn't have access to that data, but we were still consuming too much information. So, what should we do then? Any idea? Yeah, I was considering just dropping my PC and going to the field. And okay, first thing, I know what you're thinking. I should have commissioned this picture to Miguel's wife. But basically, this is completely wrong, inexact, and incomplete schema of an Ember request in FastBoot. Okay, there are some details missing, intentionally missing. What we did was starting to return static values from some of those arrows. This part we did early in the process. We would check that we weren't leaking in any of the middlewares. Do you all know how FastBoot works? I see one now. Okay, it's basically express middleware, so you can have more express middleware in between. So we wanted to check that we weren't leaking in any of those previous middlewares. So what we did is like remove FastBoot, return a static response, and see if we were leaking. We weren't. Fuck. It would be so nice, right? So we went ahead. The easiest part to remove was all the components. Why? Because as Godfrey showed you yesterday, it's just taking the HTML, pasting it there, and that's it. If the leak were there, we would have followed only replacing part of the template. But sadly, next thing we did is like, okay, one thing we changed was the API. We were hitting a new API. Maybe we have something fun in the store. So we replaced the call to find. We replaced the call to find by returning a static JSON. Yes, it was there. So later what I did, and this is a bit crazy, it was like I was looking into the Ember data code and our custom adapter and serializer code, and I was doing a binary search. Like, what if I cut things here? Is the memory there? Yes, it's still leaking. And so on. This could take like, this took me like 2 days, because depending on the part what you cut, it's really, really hard to return a static value. Like if you want to return the request from your query, it's crazy what you have to do. But finally, we found the issue in the adapter. Do you want to see the issue? Yeah. Are you prepared to be disappointed? Yeah. This was the issue. What? I think the core team were worried because they might have considered DDoS the amount of time I had to check the API about headers. And it was saying headers can be a computed property. Do you want to see the fix? You're going to be disappointed. How's it going? Do you know what's going on? No? No? Sadly, I don't either. There was another person I cannot disclose working on this, and he was really pissed off at not knowing what was going on. We have theories, but those theories are not easy to check. Really, really not easy to check. I think the problem was how that value there was being injected into the application, plus being a computed property. I think it was that, because that's the only thing we are keeping a reference to the container there. But this really works. So I have only one last advice for you, and it's let go. Sometimes it's not worth it. Sometimes it's not really worth it. So thank you. Thank you all. You can ask me anything I don't know. I hope. Yes, we're back in schedule. Yeah.